Okay, class, we still are talking about our pathways. We're now talking about the motor pathways, the descending, the motor. All right, so we start first with the direct pathways, motor, and the indirect. The direct pathways are called the pyramidal tracts. The pyramidal tracts. The indirect are called those that aren't pyramidal. The pyramidal tracts deal with your skeletal muscles. Let me say it again. The pyramidal tracts deal with your skeletal muscles. The indirect pathways deal mainly with balance, gait, stuff like that. They also deal with skeletal muscles, but in a different way. So the pyramidal tracts deal with these skeletal muscles. Okay, and the indirect pathways also do too, but in more of an assisting way. Okay, let me kind of give you an idea. So I go to reach for something. Right? When I go to reach for it, I don't want to be shaken. So when I start reaching for it, I need to activate my muscles that are agonistic. That's the ones that help me. They're all working together. But I don't want my antagonistic muscles to hamper me. So the direct pathway is what I'm doing. I'm going to reach for something. I don't want to be shaken. So that involves the indirect pathways to kind of nullify muscles that would oppose me. You say, what am I talking about? Okay, I go to reach for something. I'm using my biceps muscles. Everybody pretty much knows biceps without taking this course. But in the back of your arm are your triceps. So when I go to reach for something, I want my triceps to relax and my biceps to contract. Okay? If my triceps don't relax, then I'm going to be shaking because I'm going to be in a spasm. I can't reach for something. So when you get into clinical, certain medications have extrapyramidal side effects. Let's say you took a medication and the medication said it had extrapyramidal side effects. That means it may make you start shaking. It may make you start trembling or whatever of that nature. So just to kind of point out what I'm speaking of in this pyramidal and extrapyramidal. But anyway, direct pathways, pyramidal tracts. Okay. These tracts travel down, here's the brain, in something called the pyramids. Right here is a pyramid. Now this is the underside of your brain. See, here's the brain. Here would be the pyramid right here in that front. That would be the pyramids right there. Here again are the pyramids. That's your palms. Pyramids. So these tracts are traveling down in the brain through the pyramids, and then finally I get to the spinal cord. So these are pyramidal tracts. Okay? They're in the front. So they would be up in this area here. Up in that area there. All right. So the pyramidal tracts, let's say now, let's come here. Let's say I want to move my knee. Okay, here would be, so I'm coming back now. All right, see, before I talked about, let me find it here. Where did we put it? All right. This right here was my primary somatosensory cortex. Let's just review. That was that strip at the back, which we call the postcentral gyrus when we do the brain. This was that cortex right there. That's sensory. Now I'm talking about this strip in the front. This strip in the front right here. Okay? And right here's a sulcus. So right here's the primary motor cortex. That right there. This would be it here, just like we did the other. So if I want to move let's do my arm instead of it. Okay, I'm going to move my arm, then it would be this stack of neurons in the cortex right here that would do it. Moving my arm. I want to move my arm. Okay, so that would be up here. Then I'm going to come down. Now in these pyramidal tracts is two neurons, upper motor neurons and lower. It's only two, not like in sensory it was three generally. Upper motor neurons. Okay, so I'm going to come down. Let's see. Here would be me coming down. So that would be the neuron cell body that I'm dealing with. But of course, it would be located, since I want to move my arm, it would be located right here. Unlike what they're showing there. See, what they're showing here, let me find it again, is right up in that area there. So if that's the area there, let's go here, then we're talking more about the knee there, in that area there. See what I'm talking about? Okay. So what we're going to do then, because that would be kind of the knee area, but let's say I'm over here. So then I would be over here coming down. I want to move my arm. So it would come down, all the way down, 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 down. And then it would come through the front there. See, that's where this is. It would come through the front. Okay, once it gets so far down, it's coming through the front. That's where those pyramidal tracts would be. Let me find them again for you. Those pyramidal tracts would be in the front there. Okay. And then we would come on down. So here's that front there. We would come on down. See where we are. So corticospinal, I'm coming on down. And then I'm going to decussate right here. Decussate. See, here would be the pyramids there. That's the pyramids, the front. I'm going to come down and I'm going to decussate. That's the ventral corticospinal tract. Ventral corticospinal tract coming down. Then it would decussate there. Okay? Okay? So that's the ventral. See, right here is the lateral. Now, the ventral corticospinal tract handles skeletal muscles in the trunk. The lateral corticospinal, which decussates up here in something we call the decussation of the pyramids. See, it decussates up here. So the ventral, which handles the trunk muscles, goes down and then crosses over at the level of the cord. But the lateral, which handles your arms and legs, crosses over right here, in which we call the decussation of the pyramids. Now you can't see it, but bottom line, let's get to the bottom line. Both of them are crossing over. One crosses over at the level of the cord that's coming out, and the other crosses over up high. But that means the right side of my brain is handling my left arm and vice versa. Okay? Make it simple without getting all detail. So then that would be the pyramidal. The extrapyramidal includes the brainstem, motor nuclei, ultimo, except pyramidal tracts, all called the multineural pathways, neuronal pathways. These pathways are complex and multisynaptic, but what did I tell you? They regulate balance and posture, coarse movements. They make the action you want to do more steady. The action what you want to do more steady, should we say. That's your extrapyramidal tracts. Okay? Like the reticulospinal and vestibulospinal tracts, maintain posture and balance. See, let's go up here. So like the reticulospinal tract, right? And the vestibulospinal tract. There we are. Right there. Rubrospinal from the red nucleus, control flexor muscles. Rubrospinal, flexor muscles. When I want to lift my arm up, they would steady that motion when I want to flex my arm. Okay. Superior colliculi and tectospinal tracts. We'll talk about the superior colliculi when we get to the brain a little bit. Okay. So here's the root coming from something called the red nucleus. Okay. Rubrospinal. All right. Spinal trauma, paresthesias, sensory loss, paralysis. A paresthesia would basically be, let's say you moved your hand over your leg, you rubbed your leg, and you felt that there was a difference slightly between how it felt running over your anterior leg versus the lower leg. That's a paresthesia. It's a slight sensory loss. Now, total sensory loss would be you don't feel nothing there. But a paresthesia generally is you feel something, but you just don't feel the same effect that you would have. Paralysis is totally loss of motor function. That's motor. Okay, a flaccid paralysis versus a spastic paralysis. All right, a flaccid paralysis versus a spastic. Okay. A flaccid paralysis. Now, let's do this. Okay, remember when it came to the pyramidal tract, you had an upper motor neuron. Let's go back. And then you get to the level, and then you have a lower motor neuron. Let me go back. You have an upper motor neuron. That would be this one from the brain down. And then you have a lower motor neuron. Okay, now I want you to think of the two neuron pathway as I approach these paralysis real quickly. Okay. A flaccid paralysis would be at the level of the cord. So the neuron on a flaccid coming out, that means it's all floppy, flaccid. Flaccid means you don't have any tonus. Flaccid means you have no tonus whatsoever. No tonus. Tonus is resting muscle tension. Remember we talked about that in muscle. That would be where you have a lower motor neuron. So you'd have a cut right here, a mess up right there going to the muscle itself. From here, at the level of the cord you're going to. That's a flaccid, all flaccid. Okay? So, if you had a spastic paralysis, that's damage in the upper motor neuron. So it would be paralyzed, but it would be spastically paralyzed. Spastically paralyzed. Let's go here. Which would be an upper motor neuron deal. Upper motor neuron. So an upper motor neuron lesion, anywhere in this upper motor neuron, gives a spasticity to the paralysis. Where a lower motor neuron lesion gives a flaccid paralysis. Okay? All right. We go further. So we talked about that. A transection of the cord, cross-section at any level, results in a total motor and sensory loss in the regions inferior. Doesn't take the great genius. Anything down from that, you don't have any connection to. Paraplegia, transection between T1 and L1. Quadriplegia, cervical. Because see, let's go back real quick. If you get T1, which would be right here, see what you're going to do is, then that's a paraplegia. Because you would have been below the arm level, let's say. You'd have been below where the cervical enlargement. See, here's that cervical enlargement. That's where those nerves are going to come out to go to the arms and everything. So if I get below that, because that's in the cervical, next is thoracic. If I get below that, then I still got my arms working. But if I'm up here before I get to the arms, then that's going to be a quadriplegia, arms and legs paralysis. Okay? Poliomyelitis, hopefully everything, that was a poliovirus, muscle atrophy, destruction of the ventral horn motor neurons, which then would give an atrophy, because that would be really a lower motor neuron lesion. The death generally occurs due because you can't breathe. Okay. Amyotrophic lateral sclerosis, that's Lou Gehrig's disease, progressive destruction of the ventral horn and fibers, loss of ability to swallow and breathe. You can look at these yourself. And this we've already kind of talked about. I'm not going to get into that much. All right, so we'll close here. Thank you.